A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You know, Herman, I was looking at some of the older prompts Daniel sent us from a couple of years ago, and it is hilarious how naive we all were. Back then, everyone was obsessed with the perfect mega prompt. You remember those? People were writing these 3-page essays to a chatbot, begging it to be a world-class lawyer and a Python expert and a creative writer all at once. And then they were surprised when it hallucinated halfway through the second paragraph.
It really was the Wild West of prompt engineering. I am Herman Poppleberry, and I honestly think we are going to look back on that era as the monolithic dark ages of artificial intelligence. Today's prompt from Daniel is about how that entire paradigm has basically collapsed over the last few months. He is asking us to dive into the shift toward modular microservice-centric architectures, specifically focusing on microtasks and microprompts.
It feels like the honeymoon phase of the general-purpose chatbot is officially over. We are in March 2026, and companies aren't just playing around with chatbots with tools anymore. They are building actual systems. It is what people are calling the Microservices moment for AI.
That is such a good way to frame it. If you look at the Reinventing.a report that came out on March 16th, 72% of Global 2000 companies have moved their AI agents beyond the pilot phase and into full operational deployment. But they aren't doing it with one giant model trying to do everything. They are dismantling those monolithic prompts into atomic, high-signal control artifacts.
Control artifacts. That sounds very Herman. Can we break down what that actually looks like in practice? Because Daniel specifically asked about the difference between a microprompt and a microtask. In my head, a microprompt sounds like just a short instruction, but I have a feeling you are going to tell me it is more complicated than that.
A microprompt is less about conversation and more about operational policy. Think of it as a functional constraint. Instead of telling an agent, hey, please look at this invoice and tell me if it looks okay, a microprompt is a high-signal command that forces a specific reasoning pattern. It might be a prompt that literally only says, verify invoice date against current system time and output only a Boolean true or false. It is a surgical strike. It forces the model to ignore its general conversational tendencies and prioritize a very specific logic gate.
So what is the difference between asking a waiter for something good for dinner and telling a line cook to sear this steak for exactly 3 minutes per side?
That is a rare analogy from you that actually works. And the microtask is the resulting unit of work. It is the independent, specialized action that comes out of that prompt. When you chain 50 of these microtasks together, you get a production-grade workflow. The key is that each microprompt is independent and reusable. If your verify date microprompt works well, you can plug it into 10 different agentic workflows without having to rewrite the whole system.
And that makes it easier to debug, right? Because if the system fails, you don't have to sift through a 10,000-word conversation to find where the logic broke. You just look at the specific microtask that returned an error.
That is the big payoff. We are moving away from vibe coding and toward actual system architecture, but this creates a new problem, which is what Daniel mentioned about middle-level agents. If you have 50 micro-agents doing 50 tiny microtasks, who is making sure they are all talking to each other correctly?
This is where the middle management comes in. I know you love a good hierarchy, Herman. Tell me about these supervisors.
This is where the IBM research from earlier this month gets really interesting. They have been looking at why these massive agentic systems often have what we called a nervous breakdown in a previous episode. The issue is usually that the high-level agent, the one talking to the user, gets overwhelmed trying to manage all the tiny details. So, the industry has moved toward this layered control system. You have the meta agent at the top, which handles the strategy and the user's intent. Then you have these middle-level agents or supervisors who act as tactical leads.
So the meta agent says, I want to automate our entire accounts payable department, and then it goes back to sleep while the supervisor agent actually figures out which microtasks need to happen in what order.
Precisely. The supervisor takes that broad goal and breaks it into tactical units for the worker agents. But here is the secret sauce from the IBM paper. They found that separating content generation from judgment drastically reduces hallucinations. In the old way, the same agent would write the invoice summary and then decide if the summary was correct. That is a recipe for disaster because the model is biased toward its own output.
It is like letting the student grade their own homework. Of course they are going to say they got an A+.
In this new microservice stack, you have a worker agent who does the generation. Maybe it summarizes a legal contract, and then a supervisor agent, which is a completely different instance with a different microprompt, whose only job is to verify the summary against the original text. Because the supervisor isn't the one who wrote the text, it has no ego or contextual momentum attached to the mistakes. It is just looking for discrepancies.
I like that. It is a system of checks and balances. But I'm thinking about the technical side of this. If I have all these different agents, workers, supervisors, meta agents, how are they actually communicating? Are they just sending text messages to each other? Because that sounds slow and expensive.
That is where the Model Context Protocol, or MCP, comes in. There was a huge roadmap update from Elegant Software Solutions on March 17th. MCP has evolved from just a way for a host to talk to a tool into the standard for agent-to-agent communication. It allows agents to negotiate and delegate tasks autonomously. They aren't just passing raw text back and forth. They are passing structured state and context.
So they are basically speaking a specialized language that is optimized for delegation rather than conversation.
And it is happening over much more efficient pipelines. But you hit on a major point, latency. When you move to a modular stack, you are introducing more round trips to the model. Every time a supervisor has to check a worker's output, that is another inference call.
Right, so you are trading speed for reliability. I can imagine some developer sitting in a basement somewhere screaming about how their simple chatbot now takes 40 seconds to respond because it is waiting for a committee of 5 agents to agree on the answer.
That is the microservices hell, debate that is raging on Twitter and LinkedIn right now. People are warning about orchestration debt. If you have a complex chain of 20 microagents and agent number 7 has a high latency or a minor failure, the whole chain can stutter. Tracing those errors across a distributed agentic stack is a nightmare if you don't have the right infrastructure.
Which brings us to the tools. Daniel mentioned LangGraph and the new Deep Agents framework. I assume these are meant to be the operating system for this chaos?
LangChain released Deep Agents just a few weeks ago, and it is a game changer for sub-agent delegation. It includes built-in file system-based context management. So instead of passing the entire conversation history back and forth, which eats up tokens and causes the model to lose focus, the agents can read and write to a shared state. It is much more like how a traditional computer program handles memory.
And what about security? If I have a supervisor agent that has the power to trigger a bank API based on what a worker agent told it, I would be sweating bullets.
You should be. That is why NVIDIA's NemoClaw announcement at GTC 2026 last week was so big. NemoClaw, spelled NEMOCLA, LAW, is a security stack specifically designed for agentic tool use. It provides these hard guardrails. It can intercept a call from an agent and say, wait, this worker agent is trying to move $10,000, but the supervisor hasn't provided a valid verification hash. It adds a layer of zero trust to the agent stack.
I love the name NemoClaw. It sounds like a robotic crab that guards your servers. But let's talk about the money, Herman. You mentioned FinOps for agents. Does this mean we are finally treating AI tokens like a utility bill that actually needs to be managed?
We have to. When you have hierarchical systems, your token consumption can explode if you aren't careful. If a supervisor agent gets stuck in a loop asking a worker agent to try again because the output wasn't perfect, you could spend $50 in 5 minutes on a single task. FinOps for agents is the practice of treating token consumption as a first-class architectural constraint. Developers are now setting token budgets for specific microtasks. If the invoice verification task takes more than 500 tokens, the system kills the process and alerts a human.
It is basically putting the agents on an allowance. You get 2 cents to summarize this email, and if you can't do it, you're grounded.
It is the only way to make this sustainable at scale. Gartner is forecasting that 40% of enterprise applications will include these task-specific AI agents by the end of this year. That is a massive jump from less than 5% in 2025. If companies don't get a handle on the orchestration and the cost now, they are going to go broke before they see the return on investment.
It is wild to think that the AI agent market is projected to hit $139 billion by 2034. We are talking about a fundamental shift in how software is built. It is not just about coding anymore. It is about orchestrating.
And that is a different skill set. A lot of great software engineers are struggling right now because they are trying to apply old-school deterministic logic to these probabilistic agent stacks. You can't just write an if-then statement and expect it to work every time when there is a large language model in the middle of the loop. You have to design for uncertainty.
So, if I am a developer listening to this, and I've been building these massive, monolithic prompts that are starting to fail as they get more complex, what is my first move? How do I actually start modularizing my life?
The first thing is to stop thinking about your prompt as a conversation and start thinking about it as a control artifact. Look at your long prompt and identify the pivot points. Where does the model have to make a decision? Where does it have to generate a specific format? Each of those points should be its own microprompt.
Break it until it's simple.
Well, not exactly, but you get the point. You want to reach a level of atomicity where the prompt is so specific that it is almost impossible for the model to fail. Then you use a framework like LangGraph, or even just a simple Python orchestrator to chain them together. And for the love of everything, implement observability early. If you can't trace the sub-agent chain, you can't debug the output. You need to be able to see exactly what the worker said and why the supervisor rejected it.
I think people underestimate the human in the loop aspect here too. With a modular stack, you can actually insert a human into a specific part of the chain without breaking the whole thing.
That is a huge benefit for reliability. In a financial workflow, you might have agents do 90% of the work, fetching the data, verifying the dates, checking the balances, but then the final supervisor agent flags the task for a human to give a thumbs up before the money actually moves. Because the work has been broken down into microtasks, the human isn't looking at a mountain of raw data. They are looking at a neat summary of the work the agents have already verified.
It makes the human more of a high-level auditor rather than a data entry clerk, which frankly sounds like a much better job.
It is the only way we reach 99.9% reliability. We covered the foundational shift from chat to do way back in episode 795, but what we are seeing now is the maturation of that idea. It is not just about doing anymore, it is about doing with oversight.
And that oversight is what prevents the nervous breakdown we talked about in episode 1597. If you missed that one, it is a great deep dive into why these systems collapse when you just throw more agents at a problem without a supervisor. It is the difference between a mob and an army.
An army has structure, communication protocols, and a clear chain of command. That is what MCP and these middle-level agents are providing. We are moving from the experimental script era to the agent operating system era.
I am still stuck on the microservices hell part, though. I have lived through the transition to microservices in traditional software, and it wasn't all sunshine and roses. We traded one big broken thing for 1,000 tiny things that are all broken in different ways. Are we just doing that again?
To some extent, yes. The orchestration debt is real. But the difference is that with AI, the monolith isn't just hard to maintain, it is fundamentally limited by the context window and the model's ability to follow complex instructions. A model can only keep so many variables in its head at once. By moving to microprompts, you are essentially giving the model a smaller, cleaner workspace for every task. It performs better because it has less to worry about.
So the hell of managing the connections is worth it because the individual components actually work for once.
That is the trade-off. And as tools like LangGraph and NemoClaw mature, the cost of that orchestration will come down. We are seeing the infrastructure catch up to the ambition.
It is a lot to take in. I feel like we have moved from how to talk to a robot to how to manage a robotic workforce in about 6 months.
It is moving fast. If you are in the Global 2000, you are already behind if you don't have a strategy for this. But for the individual developer or the small shop, the takeaway is simple. Modularity is your best friend. Adopt MCP as your standard for communication now so you don't get locked into a single vendor's proprietary ecosystem later.
And maybe keep an eye on your token budget before your agent decides to spend your mortgage on a very thorough investigation of a spam email.
The FinOps side of this is going to be the next big career path in tech. Mark my words. Agent Financial Architect is going to be a real job title by 2027.
I'll stick to being a sloth, thanks. It is much cheaper. But this has been a great deep dive into where the agentic world is actually heading. It feels like we are finally getting past the hype and into the real engineering.
It is a fascinating time to be watching this. The transition from chatbots to modular agentic stacks is arguably the biggest shift in software architecture since the move to the cloud.
Well, if you want to dig deeper into the history of how we got here, definitely check out our archive at myweirdprompts.com. We have covered the rise of sub-agent delegation and the move away from vibe coding in a lot of detail over the last couple of years.
And if you are finding this useful, a quick review on your favorite podcast app goes a long way. It helps other people who are trying to navigate this microservices hell find their way to the light.
Big thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a huge thank you to Modal for providing the GPU credits that power the research and generation of this show. We literally couldn't do this without them.
This has been My Weird Prompts. I am Herman Poppleberry.
And I am Korn. We will talk to you in the next one.
Goodbye.
Later.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.